And it will be a memorization thing. You'll memorize it. As you did in Algebra 2. Notice I don't do a lot of memorization for this class. However, this is one of the things I do have you memorize because you use it in calculus. It's helpful to have all these stuff memorized. So memorize for the long term, not just the short term. So first start with some simple things. Sine of theta. How do we use it before? Opposite over hypotenuse. Yeah. Now, if we extend that a little bit. Should be something like that, right? We got an angle in theta position. Now, I can make that into a triangle fairly easily. And if this is the origin, and this is my angle theta, if we went to this position here, let's call that position the point x comma y. So some x comma some y. Everybody with me so far on that? Yeah, this point right here is x comma y. So, if I was going to this point, how long is this side of the triangle? X. Because this side, we're going x units over to get this. Yeah, we're going x over. How about up? Y. And now, because we have a circle, what do you think we might want to call the third side?
Radius.
Radius. R. So x, y, and r. Do the labels make sense? Okay, we went over x, up y, and we have a radius to r if we had a circle. Now, on this triangle, what would opposite be? Y. What would hypotenuse be? R. So we can say sine of theta is equal to y over r. No, we're still doing opposite over hypotenuse. It is just, we're doing it in a more specific way, or even more general way, I should say. So cosine of theta would be what? Okay, and tangent of theta. So no, this is basically just an extension of what we did before, right? You know, so cosecant. What is cosecant going to be? And secant? And cotangent. What this allows us to do with this definition is apply sine, cosine, tangent to any angle. Meaning, if I have a triangle or an angle that's down here, I can know my x and y coordinates at that point. And I can find all the trigonometric values. Now, let's think about it. Down here, is sine going to be positive or negative? Okay, how can you tell?
Because on the left side is the origin and opposite is x.
Well, we know going down here, y is negative down here, below the origin. Right? And the radius is always positive. So I'll put a rule up here. X squared plus y squared equals r squared. Where does this come from? Or what's this another? Yeah, this is the Pythagorean theorem up here. X squared plus y squared equals r squared. So when you look at here, r is always going to be positive, right? Because x squared is always positive, r squared is always, or y squared is always positive. Two positives add together always make a positive answer. So if we were looking at this one right here, is tangent going to be positive or negative?
Positive.
Okay, how can you tell?
If you said it's always going to be positive.
No, I said r is always going to be positive.
Tangent?
Yes. So is y positive or negative here?
Negative.
Is x positive or negative?
Negative.
So you have a negative of a negative is positive. Now you'll hear a term called the reference angle. And we'll be using it fairly often, whether or not you actually refer to it as a reference angle. The reference angle is the angle, the smallest angle made with the x-axis. Now, what do I mean by that?
Wouldn't that be a straight line?
So when I'm saying that, say if we have this angle right here, there's this, and this one. Where is the closest or smallest angle with respect to the x-axis?
It's like, oh, it's on the left side.
Would be this angle right here. So over here, if we had any angle in this quadrant, the reference angle is always going to be on that side. How about if I have like this angle right here? Where would the reference angle be? Well, the nearest x-axis is right here, so the smallest angle, right there. If we were down here in the third quadrant, so like there, where is the nearest or smallest angle with respect to the x-axis?
On the left.
Right here. I should be marking these different numbers of things to indicate they're not all congruent, but it doesn't really matter if they were. And here, where would the closest angle with respect to the x-axis be? So it would be right there, that side. Remember, it's with respect to the x-axis. So it's either that side or over here, and this one's smaller. So when we talk about the reference angle, it always goes to the x-axis, and it's the smallest one you can make with the x-axis. So does this make sense now, what I mean by that? Okay? You go to the x-axis, and it's the smallest or the closest way to get there. Okay, so I have a handout. Everybody's going to fill in. So take one of these, pass them around. So this is known as your unit circle. It may look familiar, in fact it should look familiar from Algebra 2. And here's what you have, what it is. So you're going to have to work right really tiny to be able to fit it in. So, you will memorize this.
I don't remember this. I don't remember now.
Okay. So, you will memorize these whole things. Every piece of data we're going to fill in on this.
By tomorrow?
No, not by tomorrow. So, I'll tell you, we're going to build up to it. So by Thursday, it's all of it. Thursday, Friday, so this will be over the whole thing. Tomorrow, we're going to be all angles, which you already know most of them, and the 4 cardinal directions. So, yeah. So, first, we're going to call this a 0-degree angle, or 0 pi.
Wait, where's pi?
No, the outside one here is your radian.
Oh,
So, and I'm going to put below it 360 degrees and 2 pi. If it's 0 degrees or 360 degrees, 0 or 2 pi. So, up here, what's the angle straight up? So 90 degrees or pi half in radian. Over here, 180 degrees or pi. Down the bottom. Okay, 270 degrees. That's this little thing is sort of off place. Or 3 pi halves radian. Okay, there's the 4 cardinal directions with your angle. Yeah, 3 pi over 2, 270. Yeah. Remember last Thursday I said you need to start memorizing these. What would this middle angle be? 45 degrees. And this one over here, middle over here,
Water.
135. Middle down here, 225, and middle over here, 315. Okay, and then in radians, what's this first one in radians? Pi 4. So pi over 4. Here, 3 pi over 4. 5 pi over 4. And 7 pi over 4. Now, yeah, 5 pi over 4 and 7 pi over 4. Remember, you're supposed to already know these, right? From last Thursday. I said you know all these angles. Okay. This one, what's the angle? 30. So, if we start counting by 30 degrees, we have 30, this is going to be 60, this would be 90, then 120, 150, 180, 210, 240, 270, 300, 330. You know, so the angle's fairly easy going all the way around, right? So now, in radians, what is 30 degrees in radians? Pi 6. So pi over 6. Let's count by pi 6 going around. 2 pi over 6 simplifies to what? Pi third. So you have 2 pi over 6. And that simplifies pi third, right? Everybody seen that? So then we have 3 pi over 6, which is pi half.
Yeah.
And 4 pi over 6, 2 pi over 3, and then 5 pi over 6. Then you have 6 pi over 6, 6 over 6 is pi, and then 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, 3 pi half, 10 pi over 6, which is 5 pi third, and 11 pi over 6. Okay, 5 pi over 6 would be right here, then 7, 4 pi thirds, 5 pi thirds, and then 11 pi sixths. There's all the angles. Yep. Now, we also have all the coordinates. Now, we call it the unit circle. Why do we use the word unit? No. What is this base? What is the base word for unit? Which is 1. So when we say it's a unit circle, we're saying it's a radius 1 circle. So we're looking at this coordinate out here. We are directly right 1 unit. What is the coordinate? 1, 0. Does that make sense? We're saying it's 1 unit radius. So what about the top one? 0, 1, because it's 0x up 3x 1. The one on the left. And the bottom. Okay? So by tomorrow, that's what you need. Just that right now.
Wait, everything that's on there right now?
Yes.
How fast
Not tomorrow, not that fast. No. However, it'll go faster. I'll show you. Probably not. I'll probably tell you, maybe give me the equivalent of 30 degrees in radius. Or give you the equivalent of negative pi 4. or what, and then a couple other ways you can do it. Now let's think about this. Just what we have up here. What is the sine of 0 degrees?
What?
So let's think about it. Sine is y over r. What is the y at 0 degrees? 0. What is the radius? 1. So this is equal to 0 over 1, which is 0.
Wait, where's the angle?
Remember, these are the angles inside. So sine of 0 degrees, so if we go to the 0 degree angle,
Where's the angle?
right, 0 degree would be there and there. Same.
Oh. Okay.
So if I said, for example, let's say the cosine of pi half. Cosine of pi half. Okay? What is remember, cosine is x over r, right? And in all of these cases, what is the radius going to be? 1, as long as it's on this unit circle. The radius is 1. So what that means is we can just go with the x value. What is the x at pi half? 0. Which is just cosine of there. So if I said sine of negative pi half. Okay, where's negative pi half? Okay, what is the y value at negative pi half? What is the y?
Oh.
Here
What
we're,
do you have for x?
that is cosine.
Oh, how do you
Cosine is x, sine is y. Remember, over here, cosine is x. Oops. Cosine is x, sine is y. And if we're on the unit circle, radius is 1.
so,
And divided by 1 doesn't change anything. So what about the tangent of, say, 0? Okay, what is the y of 0? And the x is? The 0 divided by 1 is 0. Your tangent is y over x.
0.
Mm-hmm. Yeah.
Is it ever on the line?
Yes.
Or it is when it's the close tangent?
What is tangent of negative 3 pi over 2?
There's that.
Where is negative 3 pi over 2 going to be?
Oh, down there.
Well, negative 1, negative 2, negative 3.
Oh.
If we're counting by half, what is the y of negative 3 pi half?
Okay, you're right.
The y is 1
Oh.
over the x. Which is undefined. Yes, so everybody with me on these? The way these are working? Yes. Now we're going to fill in the rest of the circle. Now there's a little trick to this. But this one, anybody remember your 30, 60, 90 and 45, 45, 90? Okay? Let's draw a triangle here. If this is 45 degrees, and this is 1, what is each side like? What?
1 over 2.
1 divided by square root 2, which is root 2 over 2, and over here, root 2 over 2. So when you're looking at this one, the coordinates, notice that's the rule I drew just for this triangle right here. This would be root 2 over 2, root 2 over 2. And that's just using the 45, 45, 90 triangle theorem. Does that make sense? Have we got that? Okay. Now, if we look at this one, you got a 30, 60, 90 triangle. Where we know if this is the right angle here, it is 30 degrees. This is 1, because it's the radius. Does everybody see where that's coming from, right? Okay?
Yes.
Because we're looking at just this triangle right here. So we drew this straight down. Okay? How long would this side be? Half. Because The shorter side is half of the longer side, or half on a continent. This side would be
What's that?
1/2 root 3 over 2.
Right.
So it would be 1/2 times square root of 3, right? And we just write it root 3 over 2, which gives us the coordinates. Square root of 3 over 2, 1/2. If we went up 1/2 and over root 3 over 2. Yeah. So 60, we're doing the same thing, except for this time it's like that. But this is 1. And this is 60 degrees. Which means which is the shortest side?
That.
Bottom, so it's going to cap that, so it's going to be 1/2.
Right. And y.
Yeah. So 1/2 root 3 over 2. Now, this side over here, notice these two are very symmetrical, right? Is x going to be positive or negative up here? And is y going to be positive or negative? So, here it is. X is going to be negative. This point right here, this triangle, what do you notice about this triangle compared to it? They are congruent, which means how far, what do you expect the coordinates to be?
Negative.
Yeah, -1, 2, and the positive negative here.
Positive.
So positive root 3 over 2. How is this going?
Negative square root 2 over 2 becomes
Yeah.
positive 3 over 2.
And this one? A root 3 over 2, positive 1/2. And the bottom, you can tell the exact same way. Same idea. So what would this one be? Is that going to be positive or negative? Both are going to be negative. And notice, because it's straight down from that one, the x has to be the same. So we're going to have a negative root 3 over 2, negative 1/2. Here, negative root 2 over 2, root 2 over 2. And bottom, negative 1/2, negative root 3 over 2. Yeah. With a negative, tiny.
Wait, is y negative?
Y is negative both together. Both y and x are negative. Yeah, over here, and the same number, just y being negative, because x is positive. 1, 2, negative root 3 over 2, root 2 over 2, negative root 2 over 2, and negative root, not negative, root 3 over 2, negative 1/2. So if you can get the first quadrant down, you get the rest of it, right? Very easily. Now, an interesting pattern that emerges up here. I'm going to erase all of this over here. What is the square root of 4 over 2? Which is? Okay. Then I have root 3 over 2, root 2 over 2, root 1 over 2, root 0 over 2. So let's simplify all these numbers. I'm just creating them. So, what does root 4 over 2 simplify to? 1. This stays root 3 over 2. This stays root 2 over 2. What does this simplify to? 1/2. And what does this simplify to? 0. So notice this. So this says, this is root 4 over 2, root 3, root 2, root 1, root 0. And then we can do the y's in the reverse order. Root 0, root 1, root 2, root 3, root 4 over 2. You don't necessarily have to write that. I'm just showing that that's a way of thing you help memorize if you need it. And it's just an interesting pattern that I noticed. Okay, so now, when we get to Wednesday, Thursday, Friday, you might get quizzes that say something like this. What is the sine of 300 degrees? What is the sine of 300 degrees? Close. Yes, negative 3 over 2. What is the secant of 2 pi thirds? Okay, where's 2 pi thirds? Which becomes?
Negative 2.
Negative 2.